this so that I can share this with others. Yeah, welcome this Thursday evening, St. Patrick's Day, the beginning of March Madness, lots of things to celebrate today. Yeah, Tina, no breakout rooms. Thanks for introducing yourself, Jean. So tonight I'm going to be, this is the second of a 4-part webinar series that I'm running to specifically to speak to and engage educators like yourselves with these data puzzle resources. Tonight, we're highlighting a resource called The Tipping Point that looks at how a specific tundra plant, moss campion, is responding to a changing climate and what that might mean for the rest of the tundra ecosystem. And then we'll talk about how you can take this data puzzle and try to make it more local and applicable to your area. So what I wanted to just start with is, what is a data puzzle? And so this is a framework that utilizes ambitious science teaching practices and authentic data sets to help students make sense of science phenomena. So at its core, that's what this is. And the goal for tonight is for us to engage with these different ambitious science teaching practices in the context of this data puzzle. And for you to leave here tonight feeling confident in your abilities to go facilitate this data puzzle in your classroom, should you so choose. For those of you that are interested in using this in your classroom and providing a little bit of feedback, we can compensate you with a $50 Amazon gift card. And so at the end of this webinar, I'll have a Google form that I'll drop in the chat. And if you're interested in either getting a 1-hour certificate for being here tonight, or two, potentially piloting this resource in your classroom and completing a survey to give us a little feedback, you can respond to that in the form, and I'll reach out after that. So without further ado, who am I? It's really fun. There are a few new faces in here tonight. My name is John Griffith, and I'm a curriculum developer with the CERES Education and Outreach team. And CERES stands for the Cooperative Institute for Research in Environmental Sciences. It's a cooperative with NOAA and CU Boulder. So about 800 scientists from those two organizations. We work with those scientists to take their contemporary research and try to get it into K-12 classrooms. Also on this data puzzles team, my supervisor, Dr. Anna Gold, and really been fortunate to get to work with others at the university in the Department of Education, Dr. Melissa Bratton, who's a co-author of Ambitious Science Teaching. So as you can imagine, very helpful to have a co-author of that book and someone so knowledgeable of those practices be a part of the development of this framework. And Dr. Carrie Winger, who's a developer and facilitator, among other things, for a storylining curriculum program called Inquiry Hub. So some of you may be familiar with that. Not pictured here, but we need to acknowledge, like, these are 4 faces, and there are lots of other folks that have contributed to these data puzzles. Some of you are here this evening. Randy Hoff, who's here, a teacher from Whitefish, Montana, was instrumental in the development of this particular data puzzle, The Tipping Point. And yeah, there may be some others here this evening that were part of a collaborative effort last summer to try to work with scientists, teachers, and designers like myself to make these data puzzles. So there have been a lot of people involved in this, and I think that really has been to the benefit of these resources, getting those different perspectives really important. So that's who's behind all this, and where did this come from? Forgive me for those of you that were here last week, but I wanted to just take us through kind of a timeline. So my work, again, is to work with scientists to bring their research into classrooms. And when I was hired in 2019 to do this work, my focus was on the Mosaic Arctic Research Expedition. So developing resources, videos, story maps, among other resources to connect classrooms to this really historic Arctic research expedition. And we had quite a following, and when the field portion of the expedition ended, teachers were looking for ways to continue to connect their students with this expedition by analyzing data. And so we were looking around and trying to figure out like what's the landscape in terms of data analysis resources. And one that I used when I was an 8th grade science teacher, and one that many of you probably use, is data nuggets. And so we worked with data nuggets to produce a resource with them that's published on their page, and really dug into their framework and their product, and love what they're doing. But for us, we decided we wanted to try to do a few different things, incorporate and fuse those ambitious science teaching practices into this data analysis product. So we're utilizing some ideas from data nuggets. Those of you that have heard of those NSTA daily dues, borrowing some ideas from them and fusing this resource with the ambitious science teaching practices. And so that's the story behind these data puzzle resources. So you'll see elements of data nuggets, daily dues, among other things, in these resources. So some of you, I can already see in the chat, you're familiar with ambitious science teaching, what these pedagogical moves are. Some of you may be new to that. So we'll start there. Ambitious science teaching. This is a pedagogical framework with principles, practices, and tools to support meaningful and equitable science education. In my opinion, when I was in a classroom, when I'm writing curriculum, I find that when I use these practices, I am more able to integrate NGSS standards and connect those cross-cutting concepts and SEPs and make those moves more naturally when I'm using these practices. And so the practices are planning and engaging with important science ideas. This again, you'll see these practices as currently written and shown on screen are for those educators that are thinking about how to use them in their classroom. But we've already done that thinking for you and developing for these resources. So these quadrants are moved around in our model, and I'll show you that here in just a moment. Also key to ambitious science teaching is eliciting students' ideas as key resources. So really wanting to use student ideas, language, experiences as resources that help students make sense of science phenomena and science concepts. Going along with that, working with students' ideas to support those ongoing changes and refinements of thinking. And you'll see it in these data puzzles. We're really encouraging you to draw out student experiences and language and to leverage those throughout the resource. And then at the end, pressing students to construct strong evidence-based explanations and models. And you'll see how that's integrated in these data puzzles here in just a second. So like I mentioned just a moment ago, we're not having you, the facilitator, plan for these important science ideas, and instead we're asking students to identify those by reading a text. So what we've done for data puzzles is just swapped these two quadrants. So the data puzzle starts by eliciting students' ideas about a scenario that is similar to the science investigation that's going to be presented in the data puzzle resource. And so where this came from, right, when we were developing resources to connect students to the Arctic, we found like you couldn't just start talking about albedo right away and assume students knew where the Arctic was, right? We needed to use some student experiences and slow things down before we brought them to this other world and presented new information. And so that's the goal here, is that we're going to present students with that similar sort of phenomena, similar opening scenario to what they'll investigate later. And this is where we're drawing out student experiences and language and keeping track of that on whiteboards or butcher paper or Google Docs to be referenced later. After you elicit students' ideas, we dive into the science investigation by reading about scientists and their work in an interactive reading where there are different discussion prompts and different videos and data visualizations embedded in that text to help students visualize what they are reading. Included in this identifying important science ideas practice is we ask students to identify the investigative question, the question scientists are investigating, and make a prediction about that question. And then they'll investigate that question and test their prediction in this supporting ongoing changes in thinking practice. So students are going to analyze that authentic data set that is kind of presented in the text. Putting the pieces of the puzzle together at the end. So thinking about their own personal experiences, thinking about how those connect to what the scientist is studying, testing the prediction that the student has for the scientist question based on a data set, and putting the pieces of the puzzle into some explanatory model, so some sort of annotated sketch to represent their thinking. So that's the explanatory model piece, kind of putting things together. So that's the framework here. And what I wanted to do was just pause and give us an opportunity to look at the resources that are available related to this data puzzle, the tipping point. So I'm going to hop out of the slide deck here and take us to the data puzzles homepage. And I'll add that link to the chat again. Well, feel free to kind of follow along as I use this page. So all of our resources are found here in the data puzzles collection tab. Last week, we focused on this tracing carbon through the Arctic food web data puzzle. And this week we're looking at the tipping point. So there's a little bit of background information about this resource, as well as who are the scientists involved, what data sets can you expect, what standards are we hitting, as well as the teacher guide slide deck and student worksheet. We also have answer keys, but they're kind of hidden in the teacher guide, just so a student would have to do a little bit more work to find that if they were looking. All of the teacher guides for the data puzzles look the same. There's a little bit of background information about the data puzzle. And then there's a lesson overview with a sentence about what the students will do. And we break up the lesson into, this is great. You can modify quickly on the fly. So it'll tell you the different parts of that particular resource. Most of the data puzzles are 2-day resources. I think that this one's a little bit more concise. So I think you could do this in 60, 70 minutes. On the second page of each of these teacher guides, you'll find an instructional overview table with the grade level we're looking at and targeting, instructional time, different standards, the investigative question, and then some statements about what students will do. And here are the resources, the slide deck, the student worksheet, the answer key. So make sure that you're aware of where those are hidden here in the teacher guide. And pages 3, 4, and those thereafter explain the different parts of the data puzzle in a little bit more detail. So this fun pedagogical pop-up box, this was Dr. Bratton's idea, trying to just highlight to educators, what is the purpose of this ambitious science teaching practice? What are you trying to do in these 4 different parts of part 1? Eliciting students' idea. So we've got parts 1, 2, 3, 4. Anything optional is shown in a highlighted gray box. And then at the end, there are some additional resources and extensions. It turns out that these are quite time consuming and involved to make. And in all of the research that I have done, Randy's done, others have done in making this resource, like you come across a lot of interesting articles, videos, among other things. And so I'm trying to keep track of those in an additional teacher resource section at the bottom, just so you can feel free to take this and run with it in a lot of different directions in your classrooms, and those resources are available to you at the bottom. So that's what the teacher guide will look like, and I'll give you an opportunity to check out the student worksheet on your own here in just a few minutes. So we're gonna go through these different parts in terms of like the different ambitious science teaching practices and moves together here a little bit. So some of the slides that you'll see are the slides from the actual tipping point data puzzle resource, but some I've removed some and added a few just for ease in terms of presenting right now. So just know that many of the slides that you'll see from here on out are actual slides from the tipping point resource. So we're going to start with part one, the eliciting students' ideas practice, as you would do in your classroom. And the goal here is to, again, elicit student ideas about an opening scenario that has similarities to the science investigation being presented in the data puzzle. And so we're trying to draw out student experiences, ideas, and language that can be used as resources to help students make sense of complex science phenomena. And I really want to stress here, I've added this to the slide just to remind myself, like there are several different ways to facilitate this opening scenario with your students. There is nothing included in the student worksheet about the opening scenario. So it's kind of on you, the facilitator, to figure out how this might look in your classroom, right? You're the experts in your classroom. You have routines established. So we want to empower you to utilize those routines. If you have a warm-up prompt and students use a notebook for that warm-up prompt, feel free to use this opening scenario as an opportunity to get students into their science notebooks and get them kind of settled in and ready for classroom with this opening scenario prompts. Some teachers that have used the resource, they use the think, pair, share strategy, and so they'll post the opening scenario, have students just think about it individually and talk to their shoulder partner, and then open that up for their whole class. And others, like Randy in the webinar here, they'll use whiteboards in small groups and have students jot down ideas or little illustrations together that they then share with the larger class. So feel free to facilitate this opening scenario piece however fits your routines in your classroom, but know that it's not included in the worksheet. I'll also add here that there were some teachers that piloted these resources that, because of time, skipped this part, and in reflecting on their facilitation strategies, really wish they hadn't, right? So this is a piece where we've seen teachers, they try to cut this in the interest of time, and this is such an important piece that we really encourage you not to do that, right? Pulling out student experiences and language is critical in the sense making process. So take the time here, even if it takes longer. I said 10 minutes here. Maybe students go off on tangents or some stories, and allowing students to share those experiences and feel involved and cared for is super important. In this case, the opening scenario is this. So every time you go to a doctor, you get your vital signs measured. These vital signs are like your heart rate, your blood pressure, your weight, your body temperature. And so in the chat right now, I'm going to ask that the 14 of us, 15 of us that are here, think about this prompt and add something to the chat to answer this question. Why do they check your vital signs? Why do they want to keep track of those year after year? Give you a few moments to respond in the chat. Awesome. So looking for changes, keeping track of things year after year. Something abnormal, right? If they're keeping track of these, if they have a baseline of what your heart rate has been for years, years and years. Like if that changes, maybe that's a red flag, you know? And so it's through here, like these are great, great comments, answers that we're seeing in the chat. And so when your classroom, right, imagine what your students might say to this question. Maybe students start to share experiences about visits to the doctor. Obviously, that can be a sensitive subject, but maybe some students are comfortable sharing things. This is where, you know, this can take a little amount of time or quite a bit longer if students are sharing these experiences. So right, we're looking, doctors are measuring these things to create some sort of best baseline to identify changes in these different vital signs. And so imagine if you could take plants to the doctor. I'm going to ask you to now think about this, and would love it if you'd respond in the chat here. What kind of measurements do you think the doctors would want to take? Right. So if you could take a plant to the doctor, this is a plant replacing the head of this patient. Right. What do you think the doctor would want to measure? Go, Gina. Yeah, maybe how it's photosynthetic rate. How quickly is it able to make food? Maybe the number of flowers, leaves. Are there any parasites? The height. When does it bloom? Cool. So thinking about when are those flowers starting to come out? When those flowers, right, attracting different pollinators and the mismatch that could be there. So, you know, these are awesome little vital signs for plants that doctors might want to keep track of. And so I crossed this question out, but this is how you would follow up with students, right? After you've established that there are these different characteristics doctors might want to measure in plants, right? They might know if a doctor might know if a plant was unhealthy, if there were changes in the height or the color or the phenology, the number of leaves, right? If those things changes. So you can kind of see like we're trying to take student individual experience of going to the doctor, why doctors are measuring your vital signs, to then like what is a plant vital sign and why might we want to measure those things in plants, and then segue into the investigation that doctors Dan Doak, Megan DeMarsh, and Bill Morris have been conducting for a couple of decades. These are the plant doctors, and so these are doctors of ecology at different universities across the United States, and they're studying the growth and survival of a specific type of plant, moss campion, in tundra biomes across a geographic range in the Western United States. And so they're particularly interested in how this plant, moss campion, and how these vital signs are affected by changes in environment. And so the particular vital signs that these scientists are interested in studying is the survival rate, the growth rate, and the reproduction rate. And for this particular data puzzle, we're going to be focusing on this reproduction rate and how that has changed with changes in environment. So these three have been going up to these different field sites across a broad geographic range in the United States for more than 20 years. And in meeting with them, they hope to continue this research for 20 more. Again, establishing those baseline conditions and figuring out like how are these moss campion plants vital signs changing in a warmer climate in these changing conditions. So hopefully you can see those pedagogical moves there, that eliciting piece. This concludes that eliciting ideas practice. And so we're going from the student's individual experience, trying to slowly make that connection to the work of these plant doctors, these ecologists, and then from there introducing this second practice of identifying important science ideas. And so after we finish this eliciting ideas step, we're going to dive into this a short reading where students are going to be asked to identify important science ideas and connect these science ideas back to that opening scenario about going to the doctor and measuring vital signs. They'll summarize key ideas by making an annotated sketch, and they'll identify and make a prediction for the investigative questions scientists are seeking to answer. And so a couple of different facilitation strategies here. We've had teachers read these sections aloud as a whole class, which would provide you the opportunity to stop, play the videos together that are embedded in the resource. We know that many of you have your own close reading strategies, and so want to again empower you to use those close reading strategies and use the routines you've already established to go through that text, either together individually, but know that there are some different tasks to help draw specific ideas out of the text. So with that, here's a slide directly from the slide deck. We're going to learn more about Megan, Bill, and Dan's work by reading this puzzle plot text. When you're reading the text, we ask you to do two things. This is what you'd ask your students: to circle and identify the investigative question and think about similarities between the reading and the opening scenario and be ready to discuss those. And so what I'm going to do right now, I'm going to pause. I'm going to stop talking. And in the chat right now, I'm going to drop a link to the student worksheet for the tipping point resource. And I'm going to give you, I'm going to say, I'll give us 5 minutes right now. I'll put up a timer. I'll give you 5 minutes to read through this puzzle plot text. And again, ask you to find the investigative question and to think about how the ideas presented in this reading could be related back to that opening scenario. So I'm going to open this window up here. I'm going to start a 5-minute timer, and your job in the next 5 minutes is to read this puzzle plot text included in the student worksheet. We'll see you in 5. Great. So, in your classroom, of course, that might take a little bit longer than 5 minutes, but in an hour-long webinar, hopefully you got the gist a little bit and were able to make some connections between that opening scenario and what's happening here in the tipping point. So you can see like lots of opportunities for you as the facilitator to stop and have conversations with students, pointing out the different field sites across a broad geographic range in the Western United States from which these scientists are measuring the vital signs of this plant here, Moss campion. And so really like a lot of different things here that you could spend, if you're talking about, I was meeting with a teacher today and, they were going to infuse this resource into their biomes unit and talk about the tundra biome. And so we've got different videos about the tundra biome. Where is it? What is it? What are the characteristics of the tundra biome? And really wanting to focus on how these plants, Moss campion, have adapted to live in this specialized environment. If that environment changes and you are a plant, Moss campion, that has adapted to those conditions, right? Like how might you respond to those changes? And that's what these scientists here are trying to measure and study. In this particular data puzzle, we're focused on that reproduction rate. And so for the purposes of the data analysis piece, we just say a reproduction rate. We don't really get into the units as much, but this is the number of seeds produced per year per size of plant. So kind of a different type of rate than we might be accustomed to, but that's what they're measuring across this range. We've got a couple different videos here. One that actually takes you to a field site in Alaska, and Dan here shows you how he conducts or shows you how he measures Moss campion for these different vital signs. And then another video here by a graduate student from the University of Colorado Boulder that does similar work, but in Colorado. And in this particular video, Grace does a nice job of talking about how changes in Moss campion reproduction or survival rates might impact other parts of the ecosystem, specifically the pollinators and the cascading effects there. So a couple different opportunities to talk about different things, whatever might be coming up for you in your class. So once you've gone through that text, you've had a chance to pause, play those videos, right? Then you come back together as a class and have some conversations trying to connect what we did in the opening scenario to what they just experienced in that, engaged with in that puzzle plot text. So thinking about the vital signs of Moss campion, what can measuring these vital signs tell Moss campion about the health of the plant? So perhaps this feels redundant for you right now, but we think for students, it's really important to keep making these connections between what the scientists are doing in the field with plants and what they experience in a doctor's office to establish, right? It's really important to create that baseline, to measure these vital signs year after year, to monitor for changes. And so these are questions that aren't included in the student worksheet, but you yourself would facilitate some conversations, whether that's with whiteboards, in the student notebook, think, pair, share, whatever strategies you'd like to use to make those connections. After you've read the puzzle plot, you've had some conversations, you've watched the video, now it's time for students to reflect a little bit on those important science ideas, and we ask that they draw and describe Moss campion plants and how they've adapted to their environment. So really key to pull out that concept, right? They've adapted to a specific environment that's changing. Record the investigative question and make a prediction about this investigative question. So I wanted to now go to the answer key. I realize that I'm kind of bouncing all around, but I think it's important that you see all the different resources that are available to you. So in this answer key here, the question is the task is for students to draw and describe moss campion plants and how they've adapted to their unique environment. So in this case, what I've created here as an example, you can see this is my tap root, which is accessing water. You can see some moss campion seeds here. The leaves have antifreeze proteins that allow them to stay warmer and not freeze in the winter. Their cushion-like shape low to the ground helps create a cool, moist environment in the summer, which helps other plants. And these pollinators and bees are attracted to the flowers on this moss campion plant. So wanting to just draw out all of those things and have students describe those. And then in this case, the question that the scientists are investigating, how is moss campion reproduction affected by temperature? And then have students make a prediction for how this plant's reproduction rate might be affected by warming or cooling temperatures. So we've got these answer keys again for each of the data puzzle resources. And once students have had an opportunity to pull out those ideas, to make a prediction, it's time to move on to that next ambitious science teaching practice where they're going to test their prediction by looking at some authentic data from these scientists. So testing their predictions against authentic data and the facilitation strategies here. One thing that Dr. Bratton learned in her research for that ambitious science teaching book, it's really important that you talk about the graphs with students before sending them on their way to identify those patterns and explain those patterns on their own. So talking about the graphs, having students work individually in pairs, that's kind of up to you and whatever the needs of your students may be. And we know that lots of you have other data analysis strategies, the WISWIM, what I see, what I mean strategy put out by BSBC, sorry, and you know, what other techniques you might use. So just encourage you to do that. And in this case, we're looking at, again, moss campion reproduction data. This is a 20-year data set across that geographic range and how reproduction rates have changed with changes in temperature. And so here is the data set that students are going to analyze. And here are the discussion prompts that we try to key you in on and you can have with students. So of course, a bar graph here, reproduction rate on the y-axis and July temperatures on the x-axis. We're using July temperatures because those are the temperatures most favorable for moss campion plants in these locations in terms of their ability to produce flowers, to attract pollinators, and then produce the seed. So using those temperatures here. So the prompts, right, after you kind of look at the graph, we make sense of these different axes, what we're talking about here. Have students identify the temperatures where the moss campion reproduction rates were the highest. Dr. Bratton's research showed that it was an effective strategy to ask students to look for specific points and explain what was going on in those points. And so in this case, you know, if we're asking them to find the highest reproduction rates, we're looking at July temperatures between 10 and 16. And when reproduction rates were the lowest, kind of anything lower than 10 degrees Celsius in July, those reproduction rates were low, and anything above 16 degrees Celsius were really low reproduction rates. And so this last question here, is it ever too hot or too cold for moss campion plants to reproduce? Or we don't see that here yet, but we do see that there's a temperature range where reproduction rates are high and really successful. And we see there are temperatures outside of those boundaries where reproductive success is a little bit less. And as temperatures continue to warm, right, who knows beyond this 18 degrees Celsius threshold what those reproduction rates may be and how that might affect moss campion plants in the tundra in the future. So this question really is to highlight, this is like the tipping point here. You can kind of make out this bell curve, hence the name of the data puzzle. And so with rising temperatures, you wouldn't do this with your students, give them the answer as I'm kind of doing now. But these moss campion plants, their reproduction rates are actually doing better with rising temperatures up to a certain point, the tipping point, kind of around 16 degrees Celsius here, where beyond that, we're not seeing that rise in reproduction rates. We're seeing that precipitous decline and kind of expecting that decline to continue in a warming climate. After you've had that conversation, you send students away. Again, you wouldn't give them that much information and have them identify different patterns on their own, and then have them kind of, after analyzing these different data sets, have them think about, like, do these data support their prediction that they've made previously for the investigative question, and why or why not? So hopefully this is part of that sense-making piece. They've made their prediction. They can look at some data, test their prediction, and figure out whether these data confirm or refute that, and explain why. And this last piece, after we've analyzed some data, is to construct an explanation for that investigative question. And so students are going to be finalizing new understandings and science ideas as they relate to that investigative question by constructing explanatory models. And so in this case, an explanatory model, and I'll show you an example here in just a moment, is just an annotated sketch for the question, right, for this data puzzle. How are reproductive rates affected by temperature? And so students can construct these models individually or in pairs. And what we've found here is that if there is disagreement amongst students about what should be in a final model, what components, what parts, how to connect those parts with arrows or zoom in windows or numbers to show changes in time. If there is disagreement with students, this is when you would utilize an instructional practice, a technique where you co-construct a gotta have checklist with your students. And for those of you that may not be familiar with this, there are instructions embedded in the slide decks about how to make these. The slides are currently skipped or hidden in the slide deck. So if you were in presenter mode like I am, they wouldn't show up. But if you in your classroom, you see that there's some disagreement, which is great. We love some disagreement. Then that's an opportunity to have conversations with students about, what really should go in these models. And you can create a public record where once students come to consensus about the different parts and how those parts are connected, once there's some consensus, you can put those on a whiteboard or a piece of butcher paper and start to make that list. And that really is a useful strategy and helps in the success of the modeling, is also just great practice in terms of argumentation and reflecting on evidence that we've gathered through the lesson. So just know that those instructions are hidden in slides in the slide decks should you need them. In this case, the final model is rather simple, and this may look very different for your students. But the students get a background image of just a circle, 3 different thermometers reflecting changes in temperature and this key. And whatever they come up with to explain that investigative question, that's what their task is here. And so in this example, you can see we've got some moss campion seeds when the temperature is rather cold. In this case, maybe we should put like below 10 degrees Celsius in this box. In here, we can see there are lots of moss campion seeds, lots of different pollinators. And this would represent the temperature range of 10 to 16. And this would represent the temperature range above 16, where we're seeing fewer seeds, a lower reproduction rate. And so just trying to make student ideas and thinking visible with these explanatory models and representative of the data that they just engaged with. After students construct these explanatory models, a lot of times I like to have students share them with a partner, share them with a small group. Maybe students feel comfortable sharing it as a whole class. It's an opportunity for students to learn with and from one another and see what other peers have come up with. The last piece after those explanatory models, we have added what we're calling a digging deeper question, or in this case, there are 2 questions to give students an opportunity to think about, to try to relate what they learned back to their communities, or to relate what they learned to a social justice issue, to relate to something bigger outside of what was presented in the data puzzle resource. So in this particular digging deeper question, I've got some text that really just describes how rising temperatures help moss campion plants reproduce up to a certain point, this tipping point. So really just trying to emphasize this tipping point idea beyond which we see a dramatic decline in reproductive rates. And so I've tried to plant several seeds, kind of pun intended there, throughout the text in this exercise to get students to think about, like, okay, well, there are bees that depend on these moss campion plants, and what happens to those bees if we don't have moss campion plants, and what other organisms depend on those bees. So trying to identify that ripple effect. There are also, like we said, other plants that depend on moss campion plants for those microclimates they produce. And so how might those other plants and organisms that depend on those plants be impacted? So wanting to challenge them to think about the cascading effects of the decline or loss of one organism in an ecosystem, and how that might affect others. And then also wanting them to think about potentially other endangered plant species or species in their communities, and what actions we may need to take to protect the endangered species in their communities. So a couple opportunities. Again, all of these resources are as Google Docs, so you can feel free to manipulate or modify these digging deeper questions to kind of fit what you're doing in your classrooms. We also thought it was another opportunity to talk about other climate tipping points, and this was an article that I came across on Twitter last week about how the Amazon is near a tipping point. It's more or less growing less resilient, and so potentially, like, not if we're losing resiliency, and we're seeing lots of fires and deforestation. If these forests aren't able to grow back in the same way, like, what might that mean in terms of a transition to different landscapes? So in that additional resource section in the teacher guide, I have some other resources that point to different climate tipping points that you could connect to from this data puzzle. So again, tried to build in some different ways that you could connect this resource with student experiences or other topics that you are have brought up in your classroom. So with that, a lot of talking at you. I guess that's what these webinars are. That's what these are for me, unfortunately. Hopefully you got something out of this. Hopefully you can see the progression. Hopefully you can see how those ambitious science teaching practices are embedded in this data puzzle resource, and those moves make sense, and you feel confident in your ability should you choose to go use this resource in your own classroom. I'm going to add a link. It's a lot longer than well, I can grab that bit.ly from this other slide deck I've got here. I'm going to grab this bit.ly link, which sends you to a Google form. And if you are interested in piloting this resource, giving us a little feedback via survey, please complete this Google form. It just gets your name, your email, and whether you're interested or not, and I will reach out to you in the next week or two to send along that survey and give you a little bit more information about that pilot. Also, in this Google form, I've added a question that says, if you want a webinar certificate, a 1-hour certificate for attending this, please also go to this Google form and click that you want that webinar certificate, and we'll send you that certificate in the next few days. So That's the Google form for this particular data puzzle, whether you're going to pilot it, whether you want a certificate or not. So that is in the chat right now. And I wanted to, while you're here, also promote a couple of other webinars and workshops that I'm going to be facilitating both this spring and in the summer. If you want to keep working with me, I'd love to keep working with you. So next week, we'll look at a data puzzle. Again, these same ambitious science teaching practices with a different concept that looks at mega drought in the Colorado River Basin. And then the following Thursday, the 31st, look at a data puzzle about mega fires and whether or not they are the new normal. So those two data puzzle webinars are coming up, as well as starting to promote a couple of different summer professional development opportunities. The Future of Forests, is a unit that I wrote about shifting patterns of post-fire succession in a warmer, drier world. And so basically across the Mountain West, fires are burning more and more of the landscape, and conifer trees are having trouble regenerating after these fires. And so some of these landscapes are transitioning to grasslands and shrublands. And so we look at lots of different data explorer tools and data visualizations from NASA satellites, some case studies, some hands-on stuff to help students explain both in writing and in models how landscapes recover after wildfires. Another workshop I'll be facilitating this summer looks at the changing Arctic ecosystem. So how the decline in sea ice might impact other parts of the Arctic food web. And so both of these are 2-day workshops. You get 10 hours of PD and have the option to purchase a grad credit from CU Boulder for participating. This is obviously a ton of stuff to throw at you here at the end on a Thursday afternoon or night, depending on where you're joining from. So I'll send this slide deck as well as this recording and links to these different PD opportunities in an email out through Eventbrite, either tomorrow or Monday. And just encourage you to click on these links, check them out, sign up if you're interested. And really, again, thank you for being here tonight and look forward to working with you more in the future, I hope. With that, I'm going to stop sharing. I'm going to